then. Today is our October 16th Fogarty GloCal Career Development webinar. Welcome, everyone. I'm Jeff Klausner. I'm a professor of medicine and public health at University of California, Los Angeles, and the host of these monthly career development series. And as you'll see over the course of the year, we have a variety of speakers with different kinds of experiences in academic medicine, research, and public health. And the goal is to expose the fellows to different career trajectories and be able to interact with different senior health professionals in research with a little bit of a focus on global health and other infectious diseases. So today it's my great pleasure to be able to introduce Professor Grant Hartzog, who is a professor in the Department of Molecular, Cell, and Development Biology at University of California, Santa Cruz. He is a molecular biologist, and his research has focused on transcription and chromatin. And more recently, he's begun work on bacterial endosymbiotic Wolbachia, which is a bacterial organism that affects up to 70%, which is pretty amazing, 70% of all insect species, as well as a number of human filarial parasites. And there's been a real interest in this area in terms of if we can interfere with that bacterial infection. We don't know exactly the best way yet, but if we can interfere with that, we can maybe have a global impact on these vector-borne diseases. In addition to his research, he's the Associate Dean in the Division of Physical and Biological Sciences at UC Santa Cruz, focusing on curricular, which means educational issues. He teaches courses in molecular biology as well as a variety of courses focused on healthcare and healthcare careers. We've shared with you his very extensive CV and his bio sketch, and I really like the idea that we're able to share speakers' bio sketches, because as you all develop your research careers, the bio sketch is one key tool or currency that is critical to develop and share, and you submit that with your research applications. So we expect Dr. Hartzog is going to present for about maybe about 20 minutes, and then we'll have questions and answers. People are free to upload their questions in the message bar. Unfortunately, I have to drop off pretty much in 30 minutes to have actually a call with the Fogarty folks, but you'll be in good hands with Dr. Hartzog and Lucia. All right, let's start.
Well, thank you, Jeff, and welcome everybody. So I think what I'm going to do today is spend the first half of our time talking about my career and various things I've done over the last 30 years. I'll tell you a little bit about my research in global health at the end, which is a relatively new endeavor for me. And then I'll go on to talk about the process of publication in peer review. And feel free to ask questions along the way. If I'm not being clear, feel free to tell me, or if I'm going too fast or you can't hear me, let us know and we'll fix that right away. So I grew up in Oklahoma, which is in the middle of the country, and moved to California when I was 13 years old and went to high school out here. And then I graduated from high school in 1980 and went to college at UC Berkeley. And after jumping around between many different majors, including business and math and physics, I ended up earning a bachelor's degree in biophysics in 1984. And although I'd done a lot of research as an undergraduate at Berkeley, at the time I decided that I probably didn't want to do research uh, purely as a career or for the only thing in my career. And so I ended up applying to medical school. And when I applied to medical school, I was clear that I wanted to learn human biology and do research related to human health. So my primary interest was still in research, but I really wanted to be focused on humans. And I ended up going to medical school at UC San Francisco, across the bay from Berkeley. Uh, I loved medical school and my classmates. It was really a fantastic experience. But I found very early on in my first year that I really desperately missed working in a lab and doing research. And so I started working in a lab on the weekends and in the evenings. And at the end of my first year in medical school, a slot opened up in the joint MD PhD dual degree program that was offered at UC San Francisco. And these programs are common at medical schools in the United States. I think close to 10% of my medical school class was in this joint program in that particular year. It's a federally funded program. And the way that program works is I did the first 2.25 years of medical school. So I did all my basic science courses in the first year, sort of disease-focused courses in the second year, and then several of my clinical rotations before entering the PhD program in biochemistry and biophysics. Then I was then a graduate student for close to 6 years. I earned my PhD, and at the end of that time, I realized that I wanted to continue my work that I'd started as a graduate student on transcriptional regulation, that I was unlikely to need access to patients or patient samples. I decided that I would just continue on purely with a research career. So rather than going back and finishing my medical degree, I went on to a postdoctoral fellowship at that point. I did my postdoc at Harvard Medical School, and I'd mainly done biochemistry as an undergrad or as a graduate student, and I decided I wanted to expand my skill set at that point. So I selected a genetics lab to work in for my postdoctoral work. And I began to study the interactions between chromatin, that is nucleosomes, and the transcription apparatus using the yeast model system. I selected that particular project because I wanted to go to work in a field where things were just taking off, where I felt like I could make an impact, where hundreds and hundreds of papers a year weren't already being published there. And I think that's a good thing to keep in mind. And I think most or all of you are already doing that by working in global health, which is a field that's not getting as much attention as it deserves. And so going into a field like that, as a young person, you have an opportunity to really make your mark right away and to establish yourself in your career. So I'd urge you to think about that as you move through your career. In 1998, I applied for and was selected for a faculty position at UC Santa Cruz. And I've been here as a professor in our Department of Molecular, Cell, and Developmental Biology ever since. So in my time at Santa Cruz, I've moved up through the ranks, assistant, associate, and full professor. And then more recently, I've become associate dean within our division. One of the great things about being at Santa Cruz is that I have wonderful colleagues. It's a supportive institution. And when we're hiring junior faculty, what I tell them is that this is the sort of place that if you're doing your science and excited and satisfied with the progress of your science, then you're going to get tenure here, and we're going to be happy for you. You get to really define your own career arc here. And if you're getting your grants and getting your research done, you're going to have a terrific career here. So it's a very supportive environment. Over the years, I've become increasingly involved in education issues here, and that led to me being selected as Associate Dean in my division to focus on those issues for all of the science students on the campus. And really, part of the reason that I've become involved in education issues goes back to my background in medical school. We don't have a medical school on this campus, but we have, like all universities in the United States, tremendous numbers of students interested in medical careers. And so those students often gravitate towards me because I at least have some background in medicine and have some sense of what it takes to get into medical school and what medical school is like. And so I tend to do a lot of advising for those students, and I've developed courses, many courses for those students over the years. So I've just sort of fell into the education piece of this over time, and it's a fun part of the job overall. So my research here in Santa Cruz, which I started as a postdoctoral fellow, focuses on the roles of a conserved transcription elongation regulator composed of two proteins, SBT4 and SBT5. These proteins are found in all eukaryotes. They're essential for life. There's a homologue of SBT5 that's also found in bacteria and archaea. So this is an ancient conserved regulator of transcription elongation. It associates with RNA polymerase as it moves down genes. And in eukaryotes, in addition to regulating the RNA polymerase, it's involved in maintaining nucleosome positions on genes, helping RNA polymerase get past nucleosomes, and coordinating the processing of mRNAs with their production by the RNA polymerase. As I mentioned more recently, I've started studying this very interesting intracellular bacterium, Wolbachia, which, as Jeff mentioned, infects 70% of all the insect species on the planet, and also infects a number of medically important human parasites, and I'll tell you more about that in a minute. Over the years, I've received funding primarily from federal agencies here in the United States, the NIH, the National Institutes of Health, and the National Science Foundation, or the NSF. In graduate school and postdoc, I had private foundation funding and fellowships. I've had funding from a local cancer charity here, as well as from internal university funds at various points in my career. It's fairly often in the US for universities to provide people, faculty with small grants as seed funding to help them get new projects started. Now that I've taken on administrative roles within the university, I've also received stipends in recognition of the fact that my time working as an administrator takes away from my time that I would otherwise spend writing grants. And so that also is helping to support my research and graduate students these days. So as I mentioned, over the years, my teaching has largely become centered on topics related to health and healthcare careers. So I start every morning by scanning newspapers for articles related to health that I can show to students in class. I have frequent interactions with healthcare providers in my local community. So I've maintained my interest in health overall over the years. I talk to colleagues on campus that do social scientists who do health-related research as well. A number of years ago, I asked one of my colleagues to give a seminar to students in an introduction to research class that I teach for freshmen. This is my colleague, Bill Sullivan. And Bill had started this project working on Wolbachia. As I mentioned, it's an intracellular bacterium that infects a number of organisms that are relevant to human health. So these include the parasites that cause river blindness and elephantiasis, diseases that affect hundreds of millions of people around the planet and are significant causes of morbidity, particularly in Africa. They also infect insects that transmit viruses that cause human diseases, including dengue, yellow fever, chikungunya, and Zika. A really interesting aspect of this is that Wolbachia doesn't naturally infect the mosquitoes that transmit those diseases. But you can artificially infect the mosquitoes with Wolbachia. And when those mosquitoes are infected with Wolbachia, then they become partially resistant to these viruses and are less likely to transmit them to humans. And there are clinical trials now where these artificially infected mosquitoes are being released, I believe, in Australia and in South America. And there's some evidence that's emerging that this is going to be an effective strategy for reducing transmission of these viral diseases, which have always plagued humanity, but seem to be becoming more of a threat with climate change. In the filarial nematodes, it turns out that Wolbachia is actually an obligate parasite. That is, that it's required for the life of these parasites. And that if you kill Wolbachia, you kill the parasite. That's a particularly important observation because river blindness and elephantiasis primarily affect populations in countries where the per capita expenditure on healthcare is very, very low. And the drugs that have previously been used to treat these diseases are expensive and must be taken over a long period of time. So the observation that we can target the bacterium rather than the parasite directly gives us a lower cost and perhaps more effective way of treating these diseases. And so my colleague, Bill Sullivan, has been doing screens for new drugs that affect this bacterium, and working with the Gates Foundation, they've discovered some leads and are pursuing those now. So we may have new opportunities to treat these diseases in a way that is appropriate and cost-effective for the populations that suffer from these diseases. So that's my broad background. Let's see. If we go back just 1 second, I think one other comment about my career path that's worth making is when I made the jump from being a postdoctoral fellow to a faculty member, you know, what are the sorts of things that you want to consider as you start applying for faculty positions? And I think one thing to keep in mind is that you want to go to an institution where you can be successful and you can be happy and satisfied with your career. And so some of the sorts of questions that I asked myself when I was looking for faculty positions were, will I gain new knowledge and skills? Will I have local collaborators that I can work with rather than compete with? And will I be going to an institution where I can be successful? Will I have the resources that I need to be successful? Will I have students to work with me to help me do my research? And will the institution be invested in my success? And so depending on what you're interested in doing, what your career interests are, what your research interests are, different institutions may be better or less well suited to helping you achieve your goals. So those are things to keep in mind. The other thing to keep in mind is that when you're offered a faculty position, you'll probably be some level of negotiation with the institution over what resources they'll provide you. And keep in mind that this is a little bit of a zero-sum game. They don't have infinite resources. And if you approach those negotiations with the idea that the institution wants you to be successful, they're investing in you, but that if they give you too much, that's less for somebody else. If you keep that in mind and approach it as a collaborative process, I think you'll find that you can enter into a very collegial negotiation with the institution and ultimately be set up for success. And so in concrete terms, what I mean for that is don't ask for the world, but ask for what you need and be willing to share. So say, well, here are the things I need to be successful. Perhaps I don't need access to this machine all the time, but can we find a way that I will have access for that resource, whatever it might be. So keep that in mind while you're looking for positions. All right, any questions? Okay, so let's talk about peer review and publication. So once you've done your research, how are you going to get it published? How are you going to spread that the results of your work out to the appropriate community? And the goal here really is to find the widest possible audience for your work, to find as many people as possible that your work is relevant for, that would potentially be interested in your work, and to get that in front of them, make sure they have an opportunity to see that. And of course, that really begins with having good relationships with your colleagues and making sure that they know about what you're up to, going to meetings and presenting at meetings, giving talks, giving posters, so people in your field who happen to be at that meeting will know about it, and who may be paper reviewers in the future. But then ultimately submitting it to a journal for publication. And so the first step of that really is to consider what is the appropriate journal for this particular piece of work. And so you want to consider a number of questions along the way. First is, who is my audience? Who do I want to see this work? In considering that question, then you'll start to think, well, who reads particular journals? So my work is I typically take a genetic approach. So the journal Genetics or Genes in Development, or in general, journals that are read by geneticists is a more natural home for my work than, say, the Journal of Biological Chemistry, which is mainly read by biochemists. So consider the audience that you want to reach and the audience that tends to read particular journals as you're thinking about this. then you need to be honest with yourself about the potential impact of the work. Is this a piece of work that's going to have a major impact of the field, that people are going to get super excited about, that is going to be widely read and deserves an audience in a very high-profile journal? Or is this an important piece of work, but more along the lines of filling in details, or a niche piece of work that maybe is unlikely to get into a really high impact journal? This is a hard thing to do, of course, because we all really put our hearts into our research, and sometimes it's hard to step back and really have an accurate sense of how excited people are going to be and what level of journal you're likely to be able to get your work into. So at that point, I would really urge you to consult with colleagues on this, have them read a draft of your paper, for example, and give you comments as you consider what journal might be appropriate for your work. Once you've decided on what journal you're likely to target, go to the journal's website and look at their instructions for authors. You know, it would be very sad for you to spend a lot of time preparing a manuscript for publication, to send it to the journal, and then to have them just send it back to you right away saying that it doesn't follow their particular instructions or expectations for the formatting of a paper. So read the instructions to authors and just make sure you follow their rules. When you submit your manuscript to the journal, you'll submit it along with a cover letter. And that cover letter is intended, or the purpose of that is to help the editor understand what the paper's about, so that the editor can make a quick initial decision about whether or not the paper is appropriate for that particular journal. So if I send my genetics paper to the Journal of Biological Chemistry, they may decide right away that, you know, their goal is to publish biochemistry papers, not genetics papers, and they might send it back to me at that point. So you need to help the editor understand why your paper is appropriate for their journal, what the major approaches and findings are in your paper, what you think the impact of the paper is likely to be on the field. And you often will also give some suggestions of people who might be good reviewers, expert peer reviewers for your paper. So the journal's a very busy person, is a person who may not be an expert in your subfield, so you're helping them do their job at this point with your cover letter. And these cover letters are generally a page, less than 2 pages in length, so they're fairly brief, but just giving the editor a quick overview of the paper. If the editor decides that the paper is suitable for this particular journal, then he or she will select expert reviewers in the field, usually 3, sometimes 2 expert reviewers, people who are not at your particular institution. And the article will be sent to those reviewers to provide an expert review of the paper. The reviewers will read the paper carefully and write a short review that will summarize the major approaches, findings in the paper, the quality of the science, the quality of your arguments. They'll determine if there are major points that you have missed or not considered, alternative explanations that might have been missed. They'll comment on whether or not you've appropriately provided references to prior work in the field, the overall level of your scholarship, the clarity of the paper, and so on. And then they'll provide a recommendation to the editor. Typically, they'll be asked to recommend either that the paper be accepted for publication, outright rejected, or revised. So usually these reviews are returned to the editor in 2 to 3 weeks after the reviewers initially get the paper. And the editor will read those reviews and come to a final decision, which will then be communicated back to you, the author. It's relatively rare for the manuscript to be accepted for publication on the first round of review, but it does happen. It's quite frequent for the paper to be outright rejected. Typically, that will be in cases where the reviewers have decided that this paper really isn't appropriate for this particular journal, or that even if all of their particular issues were addressed, that it still is unlikely to be high enough impact to be published in that particular journal. To get that kind of review is disappointing, but it's not the end of the world, and it's better to get that sort of no quickly, so you can address major concerns that came up and send the paper off to another journal. It's better to go through that process quickly than to spend many months trying to revise a paper only to get a no in the end. So we all have to take our lumps from time to time, and so you'll develop a thick skin about this sort of thing and just move your science forward. Now, a common result of this review process is that the editors see value in your paper, but they would like you to address a number of points before it could possibly be acceptable for publication. So the editor's likely to send the paper back to you along with the anonymous comments of the reviewers. So it's rare for you to know who the reviewers are. And then they'll give you some period of time, maybe 2, 3, 4 months, to address those comments and resubmit a revised manuscript. And then you go through this review process again. And at the end of that, the editor once again will evaluate the reviewer's comments and then make a decision again about the acceptability for publication. It's relatively rare for a paper to go through more than 2 rounds of review. The reviewers get worn out at that point and become less willing to review a paper for a 3rd time. And so usually that second decision is likely to be a final decision for your paper. Okay. So I think the major points are here when you're considering publishing your work is you want to start off by picking an appropriate journal. You don't want to spend a lot of time preparing a paper, going through the review process only to get a no because you really picked a journal that's inappropriate for your particular paper. You also want to pick the appropriate journal so that the appropriate audience reads your paper. You want to get your paper in front of people who count. It's important to pay attention to the journal's instructions to authors. That's a huge amount of work, but it'll save you a lot of grief if you do that. Write a clear cover letter to help the editor do his or her job. Remember, they're not necessarily an expert in your field. That cover letter needs to put your work in context so that the editor will understand what's being addressed, what the main message of the paper is, what its potential impact on the field is, why it's appropriate for the journal, and who the appropriate reviewers would be for this paper. While you're preparing your paper, consider who your potential reviewers are. You don't want to inadvertently insult a reviewer by not citing their work or addressing major models that perhaps they've put forward in the field. I can tell you from hard experience, it's really embarrassing when you do this. I wrote a paper once and I just forgot to cite a colleague's work. He was, even though I didn't see the names of the reviewers, he was pretty obviously one of the reviewers of my paper. He's a very kind person, but I pretty obviously hurt his feelings by not citing one of his papers, and I felt horrible about it afterwards, even though I got my paper published. So consider your reviewers carefully. Another thing is, in your cover letter, in addition to suggesting potential reviewers, you can also ask the editor to not select particular people as reviewers. And typically this will happen when you have a major competitor in the field who you don't necessarily want to see your work before it's published. And so you may ask an editor not to send the paper to that particular person. Depending on the editor, they may or may not honor that request. So I tend not to do it very often. And I just try and write my papers as openly and honestly as I can, trying to address all the major models in the field and providing appropriate citations and credit to others within the field, and let the chips fall where they may there. If you do get reviews back asking for a revision of your paper, or if the paper is rejected, read those reviews carefully. One of the most difficult things to do is to read those reviews and read criticisms of your work after you've worked so hard at it. So take some time, read them carefully, and if you're resubmitting the paper for publication, either at the original journal or at a different journal, address the arguments. Your cover letter on the resubmission, it's generally important to directly address all the comments that the reviewers make. I do that in a point-by-point rebuttal or point-by-point letter that addresses that. So that cover letter on the resubmission may be quite long. And try to not have a thin skin. Try not to write an angry or resentful letter at that point. There's nothing that's going to help you by taking that tone or approach on that point. And get advice from your senior colleagues, from people that have got a lot of experience in this process. They'll give you good feedback on your work. They want you to be successful. So those were the major points that I wanted to make today, and I'd be happy to ask questions or address comments if any of you have any.
Any questions? Okay, I think we have one. Make sure to unmute your microphone to ask.
Yes, Dr. Hartzog, I actually had two questions. My name is Keenan. The first question was, when you were just talking about earlier, like when you're submitting a manuscript and you're given that option to select certain reviewers, how do journals reduce like the risk of bias, I guess? Because I don't know, if you personally, like if I knew someone that I had a good relationship with, and I don't know, like you're kind of like asking a friend to look at it versus like another colleague. I was just kind of curious about that. And then my second question was in regards to like scientific journals, in regards to the impact factor of the journal. In your years of experience, how much does that actually play a role in a research career?
Thanks, Keenan. Those are both good questions. So with respect to the bias question, you know, to a large extent, science works based on an honor system with a basic expectation that people are going to play honestly by the rules. And so the potential for bias or people gaming the system is always there. And so that could be me sort of shopping for my buddies who are going to give me favorable reviews, or it may be a reviewer, you know, the review process, I didn't mention this, but the reviewers are expected to hold your work in confidence. When they're reading your manuscript before it's been published, they're expected not to discuss it with others. And of course, you know, there are no police out there making sure that they've actually done that. So those are two potential problems. I think in general, people are pretty good about playing by the rules. And of course, an experienced editor will often go to meetings in the field or consult with senior people in the field to try and avoid these types of bias. As I mentioned, your manuscript won't be sent to somebody in your own institution for the review. So they'll do that to avoid bias as well. And so those are some of the ways that people address it. There have been a few instances where I've had an editor contact me and say, you know, would you look at this paper for me? I've got 3 reviews here, and they're all widely differing in their opinions on this paper, and I need somebody else. There was one time, another time when I reviewed a paper where I was left with a very uneasy feeling about that manuscript, that maybe one of the authors had done something inappropriate. And I contacted the journal and just said, you know, I'm really deeply concerned about this. I think you need to have some other senior people in the field look at it. So hopefully that helps. Now, what was your second question again, Keenan?
It was the impact factor.
Oh, the impact factor. I hate impact factors. The journals have sort of learned how to game the system. So I think they're at best an imperfect measure of the stature of a journal or the appropriateness of a journal for your particular paper. Unfortunately, it's true that at some institutions and some countries that people's lives are ruled by impact factors. So I've collaborated with investigators in other countries in the past where their ability to be promoted up through the professor ranks depends on the impact factors of the journals that they publish in. And that's an unfortunate situation where they're really having to just focus on that when thinking about what journals they'll publish in. As you become more experienced in your field, you'll become pretty confident in your assessments of what are the appropriate journals for your papers. And if you're not in a place where the impact factor really is a direct consideration in your promotion process or in the grant process, then I would really recommend that you go to senior colleagues to talk to them about their assessments of your work and where an appropriate journal would be. I think that's going to be a much better piece of information to operate with rather than just an impact factor.
Gotcha. Thank you.
Any other questions? I have a question, Dr. Hartzog. So this is a question that's focused more. I think it's more about your career and what you were talking about,
Sure.
getting an academic career. And this is how do non-US scientists obtain positions at US institutions from your experience?
They apply. You know, at every institution I've been in, we've been very welcoming of non-US scientists, and I think the focus has always been on the quality of work that people have done in the past and the quality of their ideas for the work that they're proposing to do in the future. I think the challenge, certainly for non-US scientists who are applying for jobs here, are cultural challenges, communication challenges, and the challenge of just being known by people in the field. So if you've been working primarily outside of the US and maybe not publishing in the highest profile journals, are people going to be aware of you? Are they going to be able to accurately evaluate your work? Those are certainly important questions to ask. And so if you don't have a history of training in the US, going to international meetings where you're likely to meet US scientists and interact with them and become known by them can be quite helpful. And I'll say that, you know, these challenges also come up for American scientists who do their graduate and postdoctoral training outside of the US and then want to come back here for jobs. They're less well known by people in the field, and that can be a challenge for them as well. So sort of putting yourself out there socially, going to international meetings, introducing yourself to people, not being afraid to talk to other people, going up and talking to people at posters, asking questions at talks or after talks, and just becoming a known quantity, I think, are very important things as you move through your field.
Thank you.
Mm-hmm.
Do we have any other questions? Okay, I think there's no other. John, are you going to ask? Or okay, I think we don't have any other questions. And thank you, Dr. Hartzog. That was a great presentation, very useful.
Thank you, and good luck to all of you.
Thank you.
Take care.
Bye.
Thank you.
Mm-hmm.
Thank you.
Good thing.